This is the solution for the problem N-ary tree level order traversal. It's a very simple question, although it's labeled medium. It just relies on the basics. The goal is to return the level order traversal of the node's values. What it means is, take this example, where we're starting off with 1 as the root node. Now at level 0, we have only one element, which is 1. At level 1, you have the elements 2, 3, 4, 5, so all of them will be bundled together, like so. In level 2, you have 6, 7, 8, 9, and 10. And this is how you bundle them together again. Similarly for 11, 12, 13, and then 14. Each time you're only considering the level by level of a particular tree. Now, this kind of structure will bring forward to mind two things. Now, that should be very obvious. First is the use of data structure, the queue, and the second is using the algorithm BFS. This should be very obvious because the question itself hints at level order traversal. Okay, once we have that in mind, how do we go about implementing it? Let's go ahead and do that right now. We'll start off with the queue. I'm going to keep it as a list right now, and I'll explain why that works out. And we'll have another answer, which is going to be a list. At the end, we'll return the answer. The queue will start off with root at the level 0, which is what we want to consider starting off. Now, there is one condition which we'll keep for ourselves, which we'll keep in mind while implementing this. At each point in time, the value of the queue should only contain, like the queue should only contain nodes of a given level. This should be very obvious. At any point in time, the node should either contain 2, 3, 4, 5, or 6, 7, 8, 9, 10, or 11, 12, 13, or 14. It should not have any mix or up and down of things like that. Right? It should only have elements of a particular level. Now, this is simple, but it makes things important. So we'll call while queue, which means that while there are elements in the queue, while the level exists, in this case, the level beyond 14 would not exist. So all of the children would be none. In that case, the queue would not exist. And so we'll say while the queue exists, first of all, get me whatever elements are in there. So what do? We'll do a list comprehension and we'll extract out the value of the nodes in the queue right now for node in queue. We'll iterate over all of the elements in the queue, extract out the values and store them in the answer. What else do we need? Now we need to update this current state of the queue with a new state. And we'll call it new queue. We're going to have some values in here. And we'll say for node in queue, for children, for child in node.children. So we'll iterate over all of a particular node's children. We'll append this child to the queue. At the end, queue is the new queue. Cool. I think this should be it. Let's go ahead and run it. Cool, this works. This looks like it is the best solution, and logically speaking it is, but you can actually compress all of these lines into one simple line. We're going to use list comprehension again and say that q is equal to what? Now each time you want to append the children, so we'll say child for node in queue for child in node.children. We've basically compressed both of these for loops into one and taken all of these lines into one line. Is that it? There's also one edge case that you may miss. What if root is empty? If root is empty, this will be an empty list and this will say while queue. Now, empty list is root, but it's actually inside of another list. And in the first iteration, this will actually be true. List of list will actually evaluate to true and not false. This will evaluate to false. This will evaluate to true. So we need to take care of that because now in each of these elements for each empty list, we're going to extract its value, which does not make any sense. So let's actually do this check here and say that if root exists, do it, else make it an empty list. You can exit it right away, but that's also fine. And this is it. Let's submit it and check. Cool, this works. Now let's talk about the time and space complexities. The queue itself is storing the children at any given point of time. Take this example. In this case, this is sort of the length of the queue at any particular point of time. Now, what's the worst possible case that could happen? You have one root node and all of its children are given there. So it's sort of a flat tree. In that case, the length of the queue would be maximum of order of n. And that is the space complexity. What about time complexity? All of these operations are very simple, and even this operation, while queue, will only take order of one time. Answer.append is also order of one for each element. So it will be whatever the number of elements are in the queue, that would be the order of time. Uh, how much time will this take? Again, however many number of children there are, that amount of time will take for the this list comprehension. Again, consider that case with the tree is flat, there is one root node, all of the children are there in the next level. In that case, again, the time complexity is order of n. So that are the space and time complexities as well. Anyway, that is it for this question, N-ary tree level order traversal. If you like this or if you found it helpful, let me know in the comment section below. Or if you have more questions that you want me to try out, I'm always listening. Cool. That's it. Bye bye.